Welcome. In this particular video, we're going to find the centroid of the shaded area below it right here. Now, this method, we technically can use the integration method, but it is preferred that we would use the composite technique. Now, the composite technique requires us to know these formulas. So the x centroid is the summation of all of our the sum of all of our x centroids of each shape that we're dealing with times the areas, all divided by the sums of our areas of all the shapes we're dealing with. And then the same thing applies for y. It's just going to be the summation of all the y centroids times the areas over all the summations of the areas. Okay, so using the composite technique, you want to make sure when you're doing this. Now, this is something that I would do. I would always go ahead and visualize what type of shapes that we have here. So here we want to make sure we know that there are some triangles. We can see that there's a triangle kind of section right here. And this is kind of like a square or a rectangle, actually. It's not a square. And then we have an open half circle right here, a semicircle. And then we have a rectangular piece right here. So we can go ahead, and this is what I like to do. I like to say that the centroid of this, and I'll denote the centroid as capital C, it is the centroids of all of these areas. And now we have to make sure whatever areas are shaded, we add those together. And then the areas that are open, that have no shade, we subtract them. So here I'm going to label these as 1. This rectangle I'm labeling as 1. I'm going to label this total triangle as 2, and I wrote 1 there. It's going to be 2. And then this semicircle I'll say as 3, and then this rectangle right here is 4. So I'm going to go ahead and draw these shapes. So our centroid is going to be 1 because this is shaded, it's positive, plus 2. This is also positive because this is a shaded inclusive triangle right here, minus this, but we're going to actually subtract this. So that's what we're doing. So minus, if we see this area is subtracted here, so we're subtracting this semicircle, and I know that's not neat, minus this rectangle right here. Okay. So now that we have this stuff, let's go ahead and let's make a table, shall we? Now I'm going to go ahead and scroll down here. I'm going to start a table. Now this is what I normally like to do in my tables. For the vertical columns, I'll have about like 6 columns here. I'll write over here. So our first column is just identifying which shape we're going to be dealing with or we're going to be working with. Then it's going to be the centroid of that shape in the x direction. Then it's going to be the centroid in the y direction. And then it's going to be our total area of that shape. And then after that, the last 2 things that I'm going to put here are xi, ai, and that's just multiplying this guy right here times this guy. So that's what I'm denoting there, and we need to know what xi times ai is because by convention or by definition our formula calls for that. And then our yi, you guessed it, our yi times ai. Now, AI kind of sounds like something you're playing against in a video game, but they're kind of sometimes the AI can be difficult in a video game. Sometimes they can be a little bit easier depending on how you set the difficulty or depending on how the game works. But anyways, so let's go ahead and finish our table. So we're going to have 4 shapes here. So I should actually make 4 columns or 4 rows. So that's 3 rows. We need 1 more row. Okay, perfect. And let me go ahead and extend these lines down. All right. So now let's go ahead and fill out our table. So shape, I'm just going to put 1, 2, 3, and 4 because we already labeled these shapes. I labeled this rectangle as 1, this triangle as 2, this semicircular piece as 3, and this rectangle as 4. So now let's go ahead and find the centroids of all of these shapes. So remember, when we're finding the centroid of a shape, we want to make sure we do it with whatever we have the axis set to. So we put our origin right over here. So our centroid is going to be a distance from the origin to wherever the centroid of that shape is. So let's start with the rectangle first. Now, this rectangle has a length of 12 in the x direction. So over here, our x centroid of this rectangle is going to be 6 inches. Now, I'm not going to put the units because if I were to put the units, I would have to apply all the units throughout all of these columns. So I'm going to say units in inches right there. Units in, but you know exactly what I'm saying. So that's the centroid in the x direction of this piece. Now in the y direction, it's exactly in the center of this rectangular piece. So what is this length or this height up in the y direction? Well, we have 2 plus 4 plus 4, which is 10. So our y centroid should be 5 inches. And our total area, let's go ahead and find that while we're at it. Now our total area of this rectangle is going to be our length times height. That's the area of a rectangle. So it's 12 times 10. It should be 120. All right. Now let's go with shape 2. So shape 2, what is the x coordinate of our centroid over here? So we know from the triangle, or at least from this right angle, it's going to be 1/3 of that distance to from the triangle right here, at least this distance. But we also need to know what this distance is too, because remember, we're adding it from the origin. Our distance is from the origin. So what is this distance right here? Well, it should be 12, right? Because we go distance 12 all the way up to this triangle. And then it is 1/3 of this length of this triangle right here. So what is this length? Well, let's go ahead. This distance is 3. This is 6 because this is the diameter of the circle. So 6 plus 3 is 9. This is 10. So within this 2 right here, this is actually a distance 1 of this little piece right here. So that would make this length of this triangle actually 6, right? So 1/3 of 6 is 2. Now, we add 2 with the distance that we have over here. So 2 plus the distance to the this leg of the triangle is 14 because we added 12 plus 2. So our x direction is 14. Now our y is going to be, again, 1/3 of this distance from this leg. So up 1/3, it's going to be, we see that this is 10, so it's 10 over 3. So that's going to be our y direction. Now our area, what is our area? And let me go ahead and erase some of this. I know it can be a little bit messy. So the area is the length times height divided by 2. That's the area of a triangle. So this bottom base is 6. This top height is 10. So 60 divided by 2 is 30. All right, now let's go ahead and do our third shape, which is the semicircular piece. Now remember, for a semicircle, let's say that this is our axis right here. We put our axis like this. The x-axis is along the diameter of the semicircle. The x coordinate of the centroid is just going to be the radius of that. So I'll denote this as r. So we'll say that this is distance r, radius. Now our y bar, or sorry, not our y bar, I'm used to saying y bar, but our y coordinate of the centroid is by using this formula. We use 4/3 r divided by pi. Okay, now that's this distance up from the x-axis up in a vertical direction. So we're going to have to apply that here. Now, okay, so looking at our figure that we have here, what is the x-coordinate of the centroid? Well, remember, for the semicircular piece alone, it's a distance r. So this distance is 3. This is our radius. It's 3. But from the origin, what is this distance all the way over here? It's going to be 6 inches. So 6 inches is our centroid. Now our y, now from the x-axis up a vertical, let's use the formula that we have here, 4r divided by 3 pi. So 4r divided by 3 pi is our y. I'll put y3 because this is our third shape we're dealing with here. So our radius is 3. So 4 times 3 divided by 3 pi. And it should just be 4 over pi. So let's go ahead and put that right here. 4 divided by pi. All right. Now our area, the area of a semicircle, is half of that of an actual circle. So it's pi r squared divided by 2. So the area, pi r squared divided by 2. Our radius is 3. So if we go ahead and plug this in, it's going to be 9 pi over 2. That's going to be our area. Now remember, our area is going to be subtracted because this is not shaded in. It's in fact open. So this is actually going to be a negative value. Again, I repeat, this is a negative value because this is not a shaded area. We're subtracting this area to find the centroid. So you can already guess that this area is going to be negative too because this is also not shaded. So that's something to keep in mind, is when you're subtracting areas, you put a negative sign in your little table that you have here. All right, so let's go ahead and solve for the our fourth centroid and the area. So in the x direction, we should have the centroid to being 12 again. And from our y up to here, now this height is 4, right? So that means this distance over here is 2 plus 2, so that's 4. The distance vertically up to the centroid of this rectangle, so it's going to be 4. And the area of this rectangle is, so the length of this is 2, the height of this is 4. So the total area is 8, and it's negative, so we already put that. All right, now that we have done the meat of our work here, now all we have to do to fill out for our xi times ai and our yi times ai is just simply multiplying. So we multiply 6 times 120 to get xi ai for our first shape. So if we do that, 6 times 120 is 720. And then 5 times 120 should be 600. Okay, now let's go to the second shape. 14 times 30 is 420. Right? Yeah, 420. And 10 over 3 times 30 is 100. Well, not 1,000, 100. Okay. Now, when we multiply our second, our third, and fourth areas together with our centroids, we notice we have to multiply with the negatives too. So when we multiply with our negatives, these are actually going to be negative too. And I'm just going to go ahead and write them out at the beginning so that way we don't forget about multiplying the negative, because it's oftentimes easy to forget about the little negative there. So we need to keep that in mind. So let's go ahead and do that. So 6 times 9 pi over 2, that's going to be 27 pi negative. Now 4 over pi times negative 9 pi over 2. So pi's cancel out. We get a 2 on the top, so it's negative 18, I think. Yeah, negative 18. And then on the bottom, we have 12 times negative 8, which is negative 96. And for yi times ai, 4 times negative 8, we get negative 32. All right, so we have now completed our table. Now, the next thing that I'm going to do is for our formula, we need to know the sum of all of the xi AIs, yi AIs, and the sum of all the AIs. So let's go ahead and sum all of these three components right here. So I'm going to go ahead and do that. And to sum, it's just basic addition and subtraction. So if I go ahead and plug this into my calculator, so 9 pi divided by 2, and that's negative. So let's go ahead and multiply that by negative 1, plus 30 plus 120 minus 8. So this total area is 127.86. And then go ahead and do this. So 720 plus 420 minus 27 pi minus 96 should be 959.17. So let's go ahead and write that, 959.17. And this is 600 plus 100 minus 18 minus 32. 600, oh, forgot to carry that over, 600 minus 18 minus 32, and we got a grand of 650 over here. Now remember, this is us doing the summation of all of these. So I'm going to put a sigma right here to denote that this is what we're summing up here. And so now that we have finished completing summing up all of those terms, let's go ahead and solve for our x-coordinate centroid and our y-coordinate centroid. So we have, I'll rewrite the formula right here again. Again, to recap, it is the xi times ai sum divided by the sum of the ai's. And our y-coordinate is the same thing, except it's just our yi times ai sum divided by the ai sum. Ooh, bad sigma. Okay. So now let's go ahead and plug and chug. So xi ai sum is, let's see, it is 959.17. We look down at the vertical column, 959.17. And our total area, the sum of all of our areas, is 127.86. 86. This is a 7. And then for our YIAI sum is 650 down here after we concluded our sums. Divided by our total area, again, it is 127.86. Now let's go ahead and solve for the x coordinate of the centroid and the y coordinate. Actually, I might have room to write it here. So I'll plug this in the calculator really quick and see what we get. And we should get, so 959.17 divided by 127.86. It is 7.50. Okay, I'll leave it as 7.50 inches. And our y coordinate is 650 divided by 127.86. That gives us 5.08 inches. 5.08. Draw a better 8. There we go. All right, so there we go. That is the centroid, and I'll go ahead and rewrite this here. So our coordinates of the centroid is 7.50, comma, 5.08 inches. So this is our solution set of this monster. All right, hope you learned something today, and I hope to see you in another video.